And we should be live, right? I can't see my video feed. Just a second. All right, got it. An excellent connection, as it should be. I'm gonna close this. Should be. Pop the chat out. All right, and I think we can start now. Hey guys, what's up? It's 11 a.m. and I did not do a lot of questions yesterday. I was very tired, so I thought like I'm gonna start the day with this. And I watched this video. So just before starting the stream, I watched this entire video, learned about a few patterns. I learned about three patterns mainly. Let me just, all right. So one of them is, well, counting all the subsequences. So it's a take and not take pattern. And so there's a there's a base case. There's a function call where you don't take whatever element. There's a function call where you do take the element. That's it. Then there's another pattern where if you wanna uh, if you wanna stop the recursion, if it's and this is a void, right? Returns a void type. There's another pattern where you stop the recursion if you get a single correct answer. So if it matches a condition and it returns a boolean, supposed to return a boolean. So there's the base case, and inside the base case, if you reach the condition, if condition, then return true. Uh, I've got a very bad handwriting. Else you return false. I'll just do cursive. That should be better. Right. Else return false, and then inside the actual function, you do the two function calls or whatever the function calls are, and you see if they're equal to true. If they are, well, then you return true, right? God, my handwriting is bad. If they are, and do both of the calls. Right, basically that. And in the end, it returns false. Return, oh God, that's foreign which. Right, so there's two patterns and another one where you count the number of, well, the valid conditions. So it returns an int, and what you're going to do is there's a base case. Inside the base case, if it matches your condition, then return 1, else you return 0. And inside the function calls, you just store it as, well, you can say left equal to this, whatever the function is, right equal to whatever the function is, and then you return left plus right. So these are the three patterns that I was told should sum up dynamic program and recursion, these sort of questions. So I put a check right here, and we're gonna go on through all of these questions, check if there exists a subsequence with some k. All right, let's start. And add a error in the target sum k, check whether there exists a subsequence such that the sum of all elements in the subsequence equals the given target. So we did do submissions yesterday for these questions, but it had a time limit exceeded, right? Yeah. No, wait. These are just all the submissions. Fucking no. Okay, so right. Bool check subsequence NARR We need to check if it's equal to k. Well, I'm gonna create a helper function. We pass in k to it, obviously we do. and then we pass in the index and uh, for int k int index, and then we're gonna pass in the vector. And let's pass it by reference so it does not take more time copying the whole array. All right, we'll add more things as we go. So if index is equal to array dot size, well, then we've reached the base case. Let me just write the base case right here. Base case, and if it meets the condition, that is, well, okay, we need a sum later. Int sum k0 arr, and the sum is 0 right now. And array I is positive. That's something. Oh, if index is equal to array dot size, then if sum is equal to k, return true. Return false. Index equal to array dot size. This is the base case function call. Take the element. Right, if you take the element, then we pass in helper k index plus 1 arr sum plus arr index. Element. And I also practice typing like I said I would. So I'm a little more comfortable with the keyboard now. That should be helping me program all this shit. Array sum, because we're not gonna take it, right? And if this return true, so this stops the recursion in its tracks before it can do anything. It slows down our program. If this return true, and then if none of them return true, you return false. K0 array 0, and you just return this. Your program took more time than expected. So there's another thing that we can do. I noticed this. Right. So array I is lies between 1 and 1000. We can add another case if I should add it below this. If sum is greater than k, done false, because no need to go further. Because you won't find it. Yeah, see, that was the basis that was missing. Nice. That's really nice. I feel so proud of myself. Got that done. Just goes to show you that there's a lot of ways, a lot of patterns that you just have no idea about. That's gonna, that's the right question, combination sum. A lot of patterns that make all of this easy. I was talking to a friend of mine yesterday, and like there was this third guy, he just He showed us a lead code question. My friend's really good at this, and he instantly figures out like this is a coin addition problem, something like that. I have got no clue, but the way he figured out those patterns, it tells me something about this entire shenanigan. You just need to get to know the ways that these questions are designed because there is a limited number of ways you can design a question, right? Given an array of distinct integers, candidates, and a target integer target. So candidates is a array of distinct integers. Distinct, okay. Target integer target. Return a list of all unique combinations of candidates where the chosen numbers sum to target. You may return the combinations in any order. The same number may be chosen from candidates, an unlimited number. Huh? The same number may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. The test cases are generated such that the number of unique combinations that sum up to target is less than 150 combinations for the given input. What the fuck? What the fuck? Okay. Candidates I lies between 2 and 40. All elements of candidates are distinct. That's an interesting question. I need to figure something out. So it has distinct elements. So it's a set. Candidates, and then it needs to be equal to a target. We need to return a list of all the unique combinations of candidates. Or the sum to target. We want to return the combinations in any order, so that's nice. The same number may be chosen from candidates an unlimited number of times. Two combinations are unique if frequency of at least one of the chosen candidate, one of the chosen numbers is different. So first of all, I need to create a vector int called answer, right? And then I need to call a helper function. This helper function gets in my answer. And let's start designing the function on the side. Uh, void helper vector and, and that's incorrect. Needs to be a vector of vectors and needs to be passed by reference. Okay, and then I get the candidates. I'm gonna pass it by reference so we don't waste time copying the whole array. I'm not gonna play around with it. And then I'm gonna pass in an index. The index is important, right? Well, let's just get all the statics out of the way first. In target, answer, candidates, target. So we're gonna start with the index of 0 and then sum. And sum is gonna be 0 too. Alright, so let's start with the base case. If something, then do something and then return. Right? And what is something? I'm gonna Okay, what I'm gonna do is I'm gonna choose the first candidate. I'm gonna add it to the, well, I need an array that I can add it to. So we're gonna create that, and it's gonna be another constant variable. So add it after target. If index, not even index, bro. We've got 2, 3, 6, 7, and we've got the target as well. So what we can do is, so we're at the first index, we choose 2. How many times? 7 by 2 times. So that's 2, 2, 2. And then we go, I need to add another base case if sum is greater than, because all of these are positive, right? Candidate I is positive. If sum is greater than target, then you return, you don't do anything. Okay. So and to I equal to 1, I is less than equal to uh, target divided by whatever I is, not I, whatever the index is. So that's candidates index, and I'm gonna add that to my array. Cur dot push back I, candidates I, cur dot push back candidates I, right? No, I is index. Hold on. Right, so now we've got this array that has 3 twos, and while, and now I'm gonna create a function call that moves forward, and each time, so wait, call helper with answer candidates target cur index plus 1. Um, okay. Let's see, candidates index. It's gonna come back here, right? It's target minus some. Hmm. So initially it's just 7 minus 0 because the sum is 0 divided by candidates index, that's candidates 0. So 7 by 2, that's 3. 1, 2, 3. We go it 3 times. 1, 2, 3. Carry dot pushback candidates in 1, 2, 3. Sum plus equal to candidates 1, 2, 3. Candidates. So that's 2, 2, 2, and my sum is 6. Wildcard dot size is not equal to 0. Helper answer candidates target. We pass in the vector with 3 2's. We add 1 to the index and we give it the sum, and then we're gonna remove cur dot pop back sum minus equal to candidates index, and then we're gonna pass that in. So we get another call with 2 2's, and then we get another call with 1 2 3 2's. We get this call, pause this call, and then it does nothing. And so we've got all our function calls right here. Uh-huh. And then it just returns, I guess. If index is equal to well, there's another possibility that you just don't take the current element, right? Because, yeah, and then you pass this in helper answer candidates target. Where's the answer? Fucking, where's the answer? Oh God. This is complicated, bro. Answer is constant. Don't need to do anything to it. Candidates target, we get curve, which is empty, index plus 1, and the sum, which should be 0 by now. Yes. Take, don't take, and current element to array max times calls with max to one of current element. Don't take this element. Function call or don't take this element. Right. And now, and if at any instant sum is greater than target, well, you just return. So it saves us a lot of function calls because right, these are all positive, and if index, that is we've processed each one of them, right? Only get to the base case then, right? Otherwise, I don't know. For now, let's play it safe. And if index is equal to candidates dot size, next lesson. Right. Candidates dot size. If sum is equal to target, uh, answer dot push back current, and then you return the answer. Okay. Let's submit the solution. And it's wrong. I've got 2, 6, and just 7 for some reason. Why did I get 2, 6 in this? Okay, it pushes it once. So it's 2, and then it's 2 right here. It's 2, 2, and then 4. 2, 2, 2, and then 6. And then we get it here. It passes in 2, 2, 2, and then it's 2, 2, and then 4. Then it passes in 2, 2, and then it's 2, and then 2, and then passes in this, and then it's nothing, and then it's 0. This, on the other hand, gives me nothing. I only get 3 and 5 right here. I should have gotten 2, 2, 2, 2. Well, why didn't I get 2, 2, 2, 2? Uh-huh. Once again, let's target. Again, let's target curve index sum. Okay. I'm gonna take a small case. So 2, 3, 5, and then 8. And then we're gonna make a dry run out of it. And that should give me some good practice for my interviews. Right. 2, 3, 5, and the target is 8. So I've got my function call. Answer is just that. Answer candidates is just that. 8. Okay, so the function call is an empty array. 0 and 0, which are the index and sum. Okay. Is sum greater than target? No, it's not. Index is equal to candidates dot size. It's not. Okay. I equal to 1 is less than equal to target minus sum. Divided by candidates index. Target minus sum is 8 divided by candidates index. Candidates 0. It's 2 8 by 2, 4. And I plus plus. If we get 0, which it cannot, it cannot get 0, right? Because it starts with 2. It does. Alright, anyways, so we've got curve dot pushback. 1 2 3 4 candidate 0. So it becomes 2 to 2 2. And then sum becomes 8. Vulgar dot size is not equal to 0. Helper. So candidates target. So that's 2 2 2 2. Index is 2. Sum is 8. Huh? Sum is 8. Right, what does this call? F2222. Index is 1. Sum is 8. You go right here. Sum is greater than target return. That's not. Sum is equal to target. It is. So the answer. It should have been in my answer. Why is it not in my answer? Um, that's interesting. I just wanna be the one. I wanna be the one. I just wanna be the one. Cause now it should have added it to answer. Why is it not being added? Huh? It's fucking weird. Right? And then it returns, right? It should have added it to the answer and then it returns and then it goes right here. This is weird. It's 1, 2, 3, 6. 1, 2, 3, 4, 5, 6. I think my solution is correct. I have no idea why it's not working. Can ChatGPT help me out? And why is it lagging? The combination sum problem allows using the same number to use a simpler structure where you decide whether to take the current number. I'm not getting the correct answer. Then problem with my approach. This is weird. In your function, cut or push back. You're popping all the elements from current, not just the ones added in this call. Well, yeah, cur already had an instance. Oh, okay. You are 2, 3 times. Sum is equal to 6. The inside will call help each time, but you're not controlling the number of twos you're removing, so it over pops elements in the previous register. You're not controlling the number of twos you're removing, so it overpops elements from the previous recursive state. Arre, bhai, I have no idea what it's trying to say to me. Uh, then inside, while cut outside is not equal to it, start popping elements calling help each time. Right, it should work though. Well, yeah, that is actually okay. I get this. The example it gave me was shitty. Need the specific optimization, just use clean a recursive structure that allows taking the same element multiple times by not moving the index or skipping to the next element. So no, my solution works and I get what it's trying to say. It's saying that, right, for this situation, it would not work because it would reach the base case. But if it was, for example, 5, let's say, not even 5, if this was 1 and this was 2, then when we are at 2, then it would pop all the way down till the size is 0. So we need to keep track of the count. I'm gonna do that, and maybe that solves my function. Int count equal to 0. And then here we're gonna make it a for loop for in I is less than count with 0. Does that do anything? For some reason, okay, I get the correct answer in this case now. And 2, 3. Okay, why does this not work for? Push it into pairs as many times as possible with exceeding target. Keep calling helper while popping one element at a time. Then you make another recursive path with skipping element. While current size, you keep calling helper with index first. Elements including those added in the previous recursive. Uh-huh. This is skipping valid combinations, overpopping, leaving request statement, incorrect state. Incorrect state. Start popping twos and calling helper. So X3. Okay, no, wait. Is this correct? You're very close in your version 6 is the original problem. There's a small issue. You never consider the case where you take 0 copies of candidate's index before trying to take one or more copies. I do though. I fucking do. I'm just gonna. Well, if I cut this and then I paste it right here, where you just skip the element, right? I just wanna be one of your girls tonight. Push candidates from. Push elements one by one to 5, subtract the count to cleanly backtrack later. After adding multiple copies, you explore all intermediate states by popping one by one and calling recursive. Well, it's not doing it. It won't do that. It's not. Without taking anyone. I should have just started from 0. like no element, one element, two element until it reaches some, exceeds some. Ah, you are calling the recursive function only after you pushed all the possible elements in that index. So no elements, count equal to 0. I'm just gonna copy this while sum is less than, what's it called? Target. We've got 0. Curve dot push back. Uh, Current dot push back. What do you push into current? Well, candidates index. And then you call the helper function. Now we add it to sum plus equal to candidates index. Yes. Oh, what a typo. Anyways, then you call the helper function with answer candidates target current. Right, so it's got one index plus one, and then sum goes right here. Checks if it's less than target. Six. I'm gonna do a call for 10, which is not okay. So I'm just gonna target minus candle side. I just wanna be the one. I don't wanna be a woman. No. I just wanna be one of your girls tonight. Next. Please fucking work. Shit gets hard. This shit gets hard, bro. Wait, did I solve the... I'm not missing. Oh God, fuck you, it's not. Oh, it's the classic optimal solution. Build combinations incrementally. At every step you decide whether to include the current element and allow reuse, or move to the next one. You backtrack after each decision to include all valid paths. Alright, let's look at the classic solution. So answer candidates target, and then vector current index. You don't even have the sum. Interesting. If target is equal to 0, target is back current. Huh. Index equal to, I think they're gonna decrement target each time. So include the current number, can reuse, current pushback candidates index, backtrack this target minus current. Yeah, it does that. Current index, current pop back, backtrack. It's gonna keep on pushing it and backtracks, exclude the current number and move forward. And that's a small solution. This is a small solution too. It's just takes a lot of mental gymnastics. So this was a nice question. I feel like I could solve it. I'm gonna rate it 3. Took a lot of time. Started with an inefficient approach. Okay. Saved to Google Sheets. Combination sum. Combination sum 2. I hate these series of problems. And there's what? 3. Ah, motherfucker. Given a collection of candidate numbers, candidates and a target number target, find all unique combinations in candidates where the candidate numbers sum to target. Each collection candidate numbers, they're not distinct this time. Okay, target number. Unique combinations in candidates. So each number in candidates may only be used once in the combination. So you can't reuse the number this time. Isn't this just a power set? Note the solution set must not contain duplicate combinations. Okay. Okay. Oh, it cannot contain duplicate combinations. So I'm going to start with what I know. And I found this to be a very nice approach just because now I know that this needs to be a vector of vectors. I'm just gonna do that. I'm gonna start with that, at least start writing some code. And then I know I'll need a helper function. And well, I don't know what it's gonna take. I know a few things it's gonna do. So we need all of the candidates, right? So we need to add it. It's not gonna return anything, it's just gonna add it when the conditions are met. So it's gonna be a void helper, right? There's gonna be a base case. Because once you start writing, you at least get the confidence to have an idea of what you want to do. Otherwise, you're just staring at a blank screen. And I think some of this is only useful because I already know the topic that this is gonna take. If I just read this, then I don't know how I would figure out if it needs to use recursion. Well, only 100. There's one thing you can do. My friend taught me this. You look at the constraints. There's only 100 of like the length only extends to 100 candidates itself. The numbers are small, so it's gonna be recursion type because the recursive depth cannot be very large, right? So that's one way you can figure it out. And so helper is gonna take a vector and call answer and pass it by reference. It's gonna get a vector int candidates. I'm gonna pass it by reference too. I don't want to modify it. It's gonna get a target, and so that's answer candidates target. Now they're not distinct, and I don't want to have non-unique combination. So if I just start from the left, so you get non-unique combinations, and you take each element, and then you start a loop, and you keep going. I don't even know how you would do it with a loop. You can though. I mean, it's just gonna be a lot of loops. La loops, la loops. Hmm. Okay, candidates goes from 1 to 50, so it's all positive again. So we can have a base case if it's greater than target. Uh-huh. And okay, if we choose this and then we don't choose this and then we move forward some. I like the approach where they just change the target. So I'm gonna do that. If target is less than equal to 0, or index is equal to candidates of size and index. Pass in the index as 0 at the start. Target is less than equal to 0. Well, if target is equal to 0, then you add it. Add something, and then you run because you're in the base case. You push back. You push back an array. So I need an array. Vector int L. I like I'm gonna make another array named curl. Right. Pass it in. I'm gonna push back. Oh god. Uh-huh. I wanna be the one. No. I don't wanna be your woman. No. Ah. So 6 minutes, understanding the question a little. And I'm developing a somewhat approach that lets me start the question at least. I'm gonna push back curl. Right? So there's a case where you don't take the current element. And you can't reuse elements, right? Only be used once in the combination. Oh, take the element. So when you don't take the element, you just pass an helper with answer candidates target 0. You increase index with 1. Pass in the current without the element. Target stays the same. And if you do take the element, you pass it in with answer candidates. These remain the same. Target minus candidates index plus 1. Honestly, I think even if I don't write this line, I'm gonna get the correct answer. These should all be unique, right? No, I feel like they're not gonna be unique. It's 7 1 and then 1 7. So that was not unique. Uh-huh, uh-huh, uh-huh. Well, if I sort the array before passing it in, that solves the question. No, it does not actually. It does not. How can I make it unique? I just wanna be the one. How can I make it unique? That's an interesting question. 10 1 2 7 6 1 5. I need to make this unique. Sometimes writing it out gives you an idea. 2 5 2 1 2. Sorting is not gonna help you. Do this. You do this. I can use a set, but then what's the point? I mean, it is a data set and I'm practicing data structures, so. Oh. 2 5 2 1 2. I choose, don't choose, and choose, and don't choose. Increase it down and use it 3 times, 2 times, 1 time. I can do that. I can sort the entire thing. 2 2 2 5 or 1 1 2 3 twos. Can maybe create a map out of it and then pass in the map to the function. Huh. Because it's all in ascending order too. Yeah, I'm gonna try creating a map. Because once I have a map, I can just go through it, iterate through the map, add it, pass it on, add it until it reaches 0, and then I go to the other one, right? Map, map. Oh, same problem. Gonna create a map of frequencies for auto I in candidates map I plus plus. Then I'm gonna pass it in. Right. Right. I need to. All right, so I've got a map that looks something like 1 1 2 3 5 1, right? So I'm gonna iterate through the map. I got a tab on my tongue going 25 over the speed limit. I'm parking. Bro, this shit gets hard. So I got three twos, 1 5 and 1 1, and I need to create some magic out of this. And if it's bubble gum bush while you settle down on your knees saying you love it. I think it's the same as sorting the list though, isn't it? You gave me butterflies and I'm staying up all night, so what can I do to make me get away you? Ooh, I'm laying down all of my vices. I'll take the sacrifices, all I can do to make me get away. Mm, I wonder where I went. Man, how long did Oh, I'm not a good singer. Mm, I wonder where I went. Man, how long did Oh, I'm not a good singer. Mm, I wonder where I went. Well, I want to listen to myself sing now. No, no. Increase it on use it 3 times, 2 times, 1 time. Right. Button. Right. Into. Alright, so I've got a map that looks something like 1 1 2 3 5 1, right? So I'm gonna iterate through the map. Holy shit, I think I need a break. I think that's what's missing because I've been just at it for an hour now. Uh, More than an hour, I think. How long? Yeah, more than an hour. Just I want to figure this out on my own. I'm gonna be so happy if I do. I'm gonna be so fucking happy if I do. Okay, so I've got a map. I add this to the map. I'm falling apart, baby. I hope you is. If you have not listened to Atlas in Motion, man, you are missing out. So for auto IT frequency id dot first color push back. So we go through it. What happened to this guy? Just a second, guys. Alright, it was nothing, so just a call from a friend in college. That's where I should probably be right now. Oh god, I'm seeing this mosquito. I wanna smack the shit out of it. Okay, so I choose from my map. I call it one and then one. That's not what I wanna do. I wanna choose it once and then I wanna move on to the other one. Choose it again. What I am not even. I can't build this algorithm in my head, so I wanna go through this once. Right, add it to this, and then I wanna choose two. Okay, that I don't know why I have a feeling. It's an intuition that it might work. So current push back, and yeah, I'll pass it by reference. Current push back, it dot first. Uh, minus minus, and then call the helper function with you call the helper function with answer, frequency, target, index, and current. And then you pop back. Or no, you don't pop back. So it goes here, takes one, and then it's zero. Goes here, takes two, again, and then it takes two again. Ugh. But what the fuck? Okay, how do you solve this question?
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be
Ah,
solving the problem combination sum 2
and I'm
from
back on
PSD sheet.
YouTube.
But before moving on to the
Trying to watch
problem, if you
this.
guys are new to our channel, please do consider subscribing to our channel. So the
So you
problem
guys
states that you'll be
should
given a
watch this with
collection
me.
of candidate numbers and you'll also be given a target number. And your task will be to find all the unique combinations in that array candidates where the candidates do sum up to the given target. Now there are something that you need to take care of. Each number in the candidates can only be used once while making the combination. The next stuff is the solution set must not contain duplicate combinations. So you can see that this is the given candidates array, which is 10, 1, 2, 7, 6, 1, 5, and the target is given as 8. So one of the possible combinations can be 1, 1, 6. The other possible combination can be 1, 2, 5. This can be also another 1, 2, 5. But if there are multiple combinations, you can just pick once. So that's the problem. So for this example, if you're asked to find the target equal to 4, the combinations will be 1 because all the combinations just need to return the one combination that gives 1, 1, 2, no duplicate combination. So this problem is basically the second version of the combination sum. So to solve this problem, the brute force that we will be following will be inspired by the part 1 of the combination sum. So let's discuss the brute force. If you want to understand the brute force, it's mandatory that before starting off with this explanation, you should have seen the combination sum 1 video that I have already made. So if you haven't seen it, pause this video, go and check it out, and then you can come back. If you have seen that video, you remember that we were allowed to pick an element once. So that is why when we pick the element from index, we always move to the index because we can pick the element once more. And whenever there was the other case of not picking, we can move to the next, that is index plus 1. So the transitions were like this in combination sum 1. But in this combination sum 2, the question states that we cannot pick element more than once. So if you're picking the element, will you stay at the same index? Obviously not. You will move to the next index that will make the state as index plus 1. It will make the state as index plus 1. And that is the only change that you need to do in order to get all the combination that does give you the sum target. From index, you just need to move to index plus 1. Because once you have picked the index, you cannot repeat it. You cannot pick it once more. So that is why to index plus 1. So if I look at the code for combination sum 1, the only change that I need to make will be over here plus 1. While picking, I will move to the next index instead of staying at the same index. But we will still miss something. Since we are carrying a list, it will not avoid the duplicates. So probably you can carry a hash set of list and you can pass a hash set over here. And once you have called this recursion, after this, that hash set can be converted, to a list of list, and then you can return this list, then return the list. So this will become something like hash set. I'm just writing a set as of now. So this can become a set. So if you add it to the set, so it will make sure that duplicate combinations are not stored. So if you remember the time complexity discussion that we did while solving the combination sum 1, we did find it as 2 to the power n into k. And this k was because you're putting a data structure into another data structure. But now the time taken will be k log n. Why will that be? Because you're putting a data structure k, that will take a length k, and you're putting it into a set now. So that's going to take an extra log n. So I can say if you follow this method, the time complexity of brute force will be 2 to the power n into k into logarithmic of something, that is the set size. So since the interviewer will not like that extra logarithmic factor, we will have to remove it. And for that, we have to modify our recursion in a bit.
Okay, so the simple solution that he did was he used a set instead of, well, a vector of vectors. But that, I feel like that's a cheap solution. And okay, he's gonna do something else. Let's see what he does with this. I thought we were almost done with the video for some reason. It's only 5 minutes in.
Different way. So let's see how are we going to do that. So this time, instead of trying pick and non-pick, we're going to try to pick subsequences. Yes. So let's see how we are going to start off it. So imagine you have a function. Okay. So assume you're starting with the 0th index and you have a target of 4 that you need to make, and you have an empty data structure. So if I ask you, can you start with the 0th index? Your answer will be yes. Can you start with the first index? Okay, your answer will be yes. Can you start with the second index? Your answer again will be yes. Can you start with the third index? Yes. Can you start with the fourth index? Yes. Now, when I say start, what does that mean? That means if you start with this 0th index, you're getting the first element of your combination as 1. Assume after that you decided to pick this third index, you get a 2, and after that you decided to pick this fourth index, you can get a 2. So probably you can decide to pick a combination in this way. So whenever I am starting with the 0th index, I can pick the 0th index. There can be a possibility, or I can pick the first index. Again, there can be a possibility of picking up the first index. I can also pick the second index, and similarly, I can also pick the third index, and again going by, I can also pick the fourth index. So these are the 5 possibilities that I can pick up as the first element. Now let me ask you one thing: if you're thinking of picking someone as your first element, so even if you pick the 0th index guy as the first element, or the first index guy as the first element, or the second index guy as the first element, will that matter? Obviously not. If you're picking 0th, first, second, doesn't matter. You're ultimately picking 1 as your first element of the combinations. So this is where you have your trick, which makes sure that duplicate combinations are not picked while recursion. Now you will understand this as I start writing the recursion tree in depth. So I decided to pick the 0th index, which will mean that since I've picked the 0th index, I will move to the first index, and my target, which was 4, will now be reduced to be 3, and my data structure will have an element 1. Now I will not perform this recursion. Similarly, I will not perform this recursion because I've already started with someone who is starting with 1. So there's no point starting with these guys again. That will give me repeated combinations. Now for the third index, can I pick 2 as the starting element? Obviously I can. So if I pick it up, my data structure will obviously have the element 2. What about my target? If I'm picking someone which is a value 2, my target will get reduced by a value 2. Hence, it will be reduced to 2. What about the index? Now remember one thing.
I got the mosquito, guys. Got the mosquito. I'm good at this. I need to get hired for this.
element? Obviously, I can. So if I pick it up, my data structure will obviously have the element 2. What about my target? If I'm picking someone which is a value 2, my target will get reduced by a value 2. Hence, it will be reduced to 2. What about the index? Now remember one thing. You require all the combinations in the sorted order. Like the combination must be like 1, 1, 2, not 2, 1, 1. So make sure whatever array is given to you, you sort it. And after that, you start preparing combinations by recursion so that you only get the combinations in sorted order. So if you're picked up 2 and you're looking for a sorted combination, you are not going to pick up anything from the left, obviously. So you will decide to pick elements from the right. So that means you'll move to the fourth index. That's very obvious because if you have picked the third index guy, the first element, or the next elements will be picked from the right. Now, will you pick the fourth index as your starting element again? Obviously not, because you already have picked someone which is a value 2, which is your
Man, this shit's bouncing right off. Bouncing right off this fucking brain of mine. So I'm gonna let my brain rest a little. The smooth brain cannot handle all this information. I'm a little tired, I think. It's been 80 minutes since I started streaming. I should take a break. Right? I'll see you guys in a while then. Should I end the stream or should I? How many questions did we do today? So I wanted to do five. Five is a lot, I know, but I wanted to tick off five topics and we only ticked off two. We need to do three more today. And we're gonna do three more today. I think I'm gonna end the stream for now. See you guys in a while.